We begin by calibrating the rotary axis unit, and we want to make sure that the sensor bar and the detection pin is connected. In the V panel, we then go to Detect Jig and click on Start Sensing. The detection sequence will first measure the length of the detection pin and then touch the sensor bar in several places. The only time you really have to do this is if you physically remove the rotary axis unit. If you leave the rotary axis unit installed on the machine, you don't have to do this every time you start cutting. The detection pin will touch the sensor bar in several different places. It will reposition itself and even turn the detection pin. Once this process has completed, you want to make sure to remove the detection pin and sensor bar. In SRP Player, you want to make sure the software is set up correctly by going to File Preferences, selecting Cutting Machine, ensuring that the model name is MDX-40A, and turning on the rotary axis unit so that the ZCL-40A is selected. Click Apply and then OK. We then import our STL file. Once imported, go to Step 2, Type of Milling. And before we begin, we want to make sure that we have the correct tools selected. So we'll go under Options, My Tools, and select the 1/8 inch and 1/4 inch ball and square end mills. And click OK when finished. And for this project, we'll be selecting a better surface finish. And because of the curves in the blade, we'll be using curved surfaces. And we'll also be using a block material that will be cut from the top and the bottom. And for this project, we will not be using the supports. And click on Step 3. The material that we'll be using is Delrin or polyacetyl. It's also known as acetyl copolymer. And enter the dimensions for the material, which for this project is 6 by 3 by 1/2 inch thick. We then select Create Toolpath, and this will generate the toolpaths required for the top and the bottom. And we can go to Step 4 to view the estimated cutting time and to view the model. This is where we get a good idea if the tools selected are good and if any changes need to be made. Here we can see that the blades are not fully cut. Looks like we have a little bit of material left on the bottom. And we can select one of the options below that says cutting doesn't reach the bottom surface. And here we can basically see that the cutting depth needs to be increased so that it goes all the way to the bottom. To change this, we can go back to Step 3 and click on the Edit button. This will allow us to edit the roughing process. and more specifically the depth. And we want to change this so it cuts all the way through, so we select the all button and click apply. The other thing we want to do is speed up the process a little bit, and we want to change the feed rate from the default to 1400 millimeters per minute and increase the spindle speed to 12,000 RPMs per minute. Everything else will stay the same. Usually just doubling the cutting speed and spindle speed is good. So we want to make sure we go to the finishing, change the cutting depth to all, change the cutting parameters for the finishing as well, and do that for the other processes as well. Again, a good general rule of thumb is if you double the default feed rate, you're probably pretty safe. And again, you also want to make sure you increase the spindle RPMs as well whenever you make any kind of spindle speed changes. Once finished, we click the apply button and then close, and then click on create toolpaths to generate the toolpaths. Once completed, we go back to preview results. We can see the estimated cutting times improved, and we want to double check our model to make sure that it cut all the way through this time. Here we can start to see that the blade has been properly cut this time. And we can click on the show model button to compare it to the original file. And everything looks good. To start the cutting process, we're going to click on step 5, perform cutting, and click on the start cutting button. This will pop up a screen that lets us know which tool needs to be installed. And before we do that, we need to install the material, which has been marked on the sides. That mark will simply just let us know where the center of the material is. When we install this center drill, this will make it easier to line up the drill to the material. We then make sure that the drill is properly centered on the material, tighten everything down, and go to the V panel and click on drill workpiece, and click the rotate button to turn the material. We then gently feed the drill into the material to cut a hole. What we're looking to do is create a little notch in the material for the live center to support the material on the right edge. Don't want to go too far. I just want to leave a little cone-shaped hole in the material. So what we'll do, once we have a nice little shape in there, we remove the live center drill. And install the live center. Which will hold the material from the right edge. We're going to make sure to tighten it, not too much. If you apply too much pressure, it'll actually bow the material and give you improper results. Next, we'll install the 1/8 inch collet into the spindle, and you may have to support the pulley so that the collet doesn't spin in the spindle. And we'll grab our 1/8 inch ball end mill and place it into the spindle. And you may have to support the tool by applying a little bit of side pressure so the tool does not fall. We then grab the 10mm wrench, then the 17mm wrench, and tighten. And once finished, click the next button, and now we need to set the X origin and move. Usually it helps me if I lower the tool to about the surface of the material and then move it to the right edge of the material. And you may have to move it fore and aft a little bit so that you get it right at the edge. And next we want to do is set the X origin. And after that's set, then we want to set the YZ origin at the center of rotation, and just simply click the apply button. And that will measure the tool length as well as set the Y origin. Once the tool has been measured, the tool will move up and out of the way. And we go back to SRP player. And we click the next button and click next to start cutting. The first pass may not remove a lot of material. It may just ride on the top surface of the material. That's normal. When the time comes to rotate the part, the SRP player will actually rotate the material 180 degrees so that it automatically cuts the bottom side. And it doesn't look like it's actually removing a lot of material, but it actually is removing about 0.008 of an inch at a time. And once cutting is finished, press the view button to bring the material forward. And here we can see the part that was created. Once we remove the piece, just get some diagonal cutters and just simply cut the fan out of the material. Once the piece has been completely removed, we can actually install it on the collet. And once we turn on the spindle, this will actually blow the chips out of the cutting area. When cutting difficult materials like acrylic, it's probably a good idea to use a fan like this.